So we're going to talk about the limit of piecewise defined functions. In this example, the question says, find the limit as x approaches 4. The function given to us has two pieces. One piece is defined for x larger than 4. When x is larger than 4, we have a square root function. Remember that for the domain of this function, it cannot be less than 4. If I plug in 1, I get square root of -3, which is in real world undefined. So let's try to graph this guy and find a good marker. So let us graph this. My x-axis and then my y-axis. And it says when x is more than 4, I have square root of x minus 4. So if I plug in 4 here, I get square root of 0, which is basically 0. Then x is 4. Square root of x minus 4 is equal to square root of 4 minus 4, which is square root of 0, which is basically 0. But since we don't have equality here, it means that we're going to use an open circle. Since in the question x is more than 4, we cannot include 4. We use an open circle. Okay, 1, 2, 3, 4, and on 4, I'm going to use an open circle. Then x is equal to, for example, 5. We end up with square root of x minus 4, which is square root of 5 minus 4, which is square root of 1 or 1. So at 5, I have a 1, and I can start, plugging 6, 7, 8, 9, 10, and get the rest of these points. If I connect these, this is the graph of square root of x minus 4 here. This is one piece of your function. The next piece is defined down here. It says, hey, okay, I know if x is more than 4, you have square root function. If x is less than 4, I'm going to graph this linear function. Very good. So let us continue. So the same as before. When x is equal to 4, I'm going to just plug this guy in here so I see what is the y value. I get 8 minus 2 times 4, which is 8 minus 8, which is 0. So at x equals to 4, this becomes 0. The same as what you see here. So that's why we keep an open circle. Since in the question x is less than 4, 4 is not included, we use an open circle. Very good. When x is 4, your y value is 0 again. So we're going to keep this open circle. Now let us continue. X is less than 4. Suppose x is 3. When x is 3, you have 8 minus 2x, which becomes 8 minus 2 times 3, or 8 minus 6, or 2. So when x is 3, my y value is 2. 1, 2. What if x is equal to, for example, 0? Any value less than 4 going to be connected to this formula. 8 minus 2x, which is 8 minus 0, or 8. 0 and 8. So we can continue this. A little bit going up. Suppose 8 is here. So I'm going to just connect these points together. I'm going to use a different color. So here you have a decreasing line. I cannot go further down. I cannot plug in 5 here because this piece of function is defined for any x less than 4. So this is your function. And this is the graph of your function, which is given in this question. Now the question says, find the limit. We have the graph, and we can analyze this both using algebra, the formula that we have, and also the graph. Now, to find the limit, of the function, since it has 2 parts, we need to find the limit from left and from right. Okay. What is the limit of function as x is getting closer and closer to 4 from right hand side? It means that I have numbers larger than 4 and they are getting closer and closer to 4. I'm getting closer and closer to 4 from right. So that's how you find the limit as x approaches to 4 from right hand side. It means that you are on this piece, this part of the function. You are on the square root function. So you're going to plug in 4 here. This is going to be the limit of square root of x minus 4 as x approaches to 4 from right hand side. Well, this is part of the domain of the function, right? So you can easily use direct substitution. By direct sub, you have square root of 4 minus 4, which is equal to square root of 0 or 0. So from right hand side, the limit is 0. What about limit from left hand side? You need to analyze the limit from left and right. If they're equal to each other, you're going to say that, hey, you have a limit at that value. Now, limit of f of x as you're getting closer and closer to 4 from left hand side. Now this side. Limit as x approaches to 4 from left, which means that you are on the decreasing line here. So calculate the limit of 8 minus 2x as x approaches to 4 from left hand side. Again, you have a linear function, nice function, direct substitution. Direct sub, you get 8 minus 8, which is again 0. Now, what is the conclusion? We're going to say that conclusion, since limit from left is equal to limit from right, or limit from right is equal to limit from left, both of them are equal to 0, we're going to say that, hey, the limit of the function as x approaches to 4 is 0. Limit of f of x as x approaches to 4 is 0. This is your conclusion. This is what we are looking for. If they are different values, then you're going to say that, hey, the limit doesn't exist.